Laser, which is the most brilliant, colorful, and powerful invention in the world. It serves the unique tools in industrial, scientific, aerospace, and so on. You must be familiar with this, the laser pointer, which is one significant class of laser. It's everywhere in your daily life essentially. Semiconductor laser. The size of laser is strongly related to its type. The conventional lasers, such as solid-state and gas laser, are bulky. The size is usually from few tens centimeters to few meters. It's constructed by many indispensable parts: game media, cavity mirrors, light pumping module, cooling system, encapsulation case. However, the laser pointer is less than 10 centimeters. Actually, if we take a look inside of laser pointer, it's usually constructed by battery, output coupling optics, and the core semiconductor laser chip, or specifically laser diode. The typical size of a laser diode is less than 1 millimeter. How to put such powerful tools in the size smaller than a rice? Thanks for the rapidly growing of nanotechnology. The fabrication of semiconductor laser basically rely on the mature lithography technique. Today, we are just focusing on the most common and also simplest type, side-emitted laser diode. The name of laser usually indicates what the game medium is. Yes, the game media of semiconductor laser is semiconductor. The most developed semiconducting materials for laser diodes is the alloy of gallium arsenic indium phosphide, gallium nitride, corresponding to red, green, and blue laser respectively. The figure shows the typical schematic of side-emitting laser diodes. It's composed by many layers of semiconducting materials in the well-designed thickness and order. Conventionally, you need a pair of high reflective mirrors to build a good cavity. For semiconductor laser, the material itself serves the cavity. It's because the refractive index of these common semiconducting materials is much higher than 1, says 3.5 to 4 in the visible range. The interface can have large angles serving of total reflection. The photons emitted in the material can be confined nicely in the game media. Back and forth induce a strong stimulated emission. The highest efficiency design is to make the top and bottom parts with the multi-layer coating block reflectors, which leads to the better confinement and high conversion efficiency. So far, we have a good cavity to confine the photons, but where do the photons come from? In conventional laser, we need a very intense pumping light to pump the electrons from ground level to higher levels, creating the population inversion, which is necessary for stimulation emissions. However, in the design of laser diode, we apply a totally different pumping mechanism called electrical pumping. Very similar to the principle of light-emitting diodes, we build a p-n junction by doping when you are growing materials. By applying current, the electron-hole pairs will annihilate in the junction and emit photons, and just inside the cavity. Then it's lasing. Design semiconductor laser is not anything else but making whole laser cheap. We make gain media with semiconducting materials. We make cavity by the total reflection and metamaterials techniques. We replace the bulky optical pumping module with highly efficient electrical pumping. Oh, how about cooling? The chip must be so hot and will burn in a few seconds, right? No, because these semiconducting materials have high thermal conductivity. In other words, we can just directly mount the chip on a heat sink. That's it, efficient and so simple.